Okay, welcome back. We're just going to pick up right where we left off here. We've already completed parts A and B of this exercise, and so now we're just going to jump into part C. So we're looking for if a randomly selected person states, forgive the typo there, states that they obtained part-time employment, what is the probability that they studied science? So what we're looking for here, this is now the conditional probability. So conditional that they obtained part-time employment, what's the probability that they studied science? So the notation, it's actually the notation is backwards compared to how you would say it. It's conditional on having part-time employment. What's the probability that they studied science? So the way that you would read this is what's the probability that an individual studied science given that they have part-time employment. Okay, so that's how you would read this, this statement. Now, how can we calculate that? Well, let's ignore the joint probability table just for now. And we have the luxury of having the numbers. Sometimes when you're working on these types of problems, all you'll have are the probability tables. And so you'll have to work with that. And we'll lead up to that. But here we have the luxury that we've got the actual data itself. So first of all, given that they're part-time, so what that means is all I'm interested in is this information here. Okay, they're part-time employment. Okay, so I don't need to worry about anything else. Now, what is the probability that they studied science? Well, out of those people who obtained part-time employment, 18 of them studied science. So having the numbers here, the calculation is relatively simple. It's 18 people out of 77 part-timers. So there's a total of 77 part-times. 18 of those part-timers studied science, and so that probability then is 18 divided by 77, 0.23. So it's fairly straightforward. We isolate, okay, I'm told that we're only looking at part-time, so I'm only going to consider those part-time values. What's the probability that they studied science? 18 out of 77.23. Okay, that's uninteresting. Now, how do we get the probability discussion, using our joint probability table? Well, consider you go to your formula sheet, and you have something that probably looks something like this. That conditional probability is an intersection, so it's the probability that they're part-time and studied science divided by the probability that they are part-time. Okay, it's something along these lines. So how can I translate these two pieces of information? How can I kind of reconcile what we're doing here? Well, if I change my calculation ever so slightly and say, well, 18 divided by 193 and 77 divided by 193. Well, in this calculation here, well, those 193s in the denominators, they just cancel out. They don't really affect the calculation whatsoever. But 18 divided by 193, right, that's 18 divided by 193, that is how we obtained that joint probability, or in this case, that intersection between part-time and science. So if we were to apply that formula, that would be 0.09 was that intersection. And then what's the probability of being part-time? Well, that's the 77 divided by 193. 77 divided by 193. Here that was 0.4. And so if we calculate this, subject to some rounding error, I suspect, divided by 0.4, there's a little bit of rounding, roughly 0.23. Okay, so we get effectively the same result with the exception of some rounding error in there. Okay, so that's really all there is to it. So for part C, we have 0.23 is the probability that, given that you've told me that you are part-time, a 23% chance that you studied science. Okay. Now if we go on to part D, let's go through this in the same manner again. So part D, if a randomly selected person states that they obtained full-time employment, what is the probability they studied business? So what's the probability that you studied business given that you obtained full-time employment? So again, if we go to having the luxury of the actual data, I can see, okay, I'm isolating my analysis here to full-time. So I'm only looking at the full-time graduates. So I have 23 of those full-time graduates studied business. So that's 23 out of a total of 116 who obtained full-time employment. So that's out of 116. And so here I can calculate that, 23 divided by 116, and call it 0.2. We'll round that up to 0.20. Now, going through our little adjustment, let me clean this up a bit. If I were to say, well, what if we divide this by 193, divide this by 193, so if I divide both the numerator and the denominator by 193, well, now I have, this is the probability that they are both full-time and business. So this is that intersection between full-time and business, divided by this 116 over 193. This is my probability that they are full-time. There's my probability that they are full-time. Now if we substitute in those probabilities, so here I had a probability, that intersection between full-time and business, so that's over here. That was a probability of 0.12 divided by the probability of being full-time, 0.6. And now let's plug that into our calculator. And I have 0.12 divided by 0.6. And wouldn't you know it, our answer is exactly 0.20. So again, we see that it's consistent regardless of how we do it. Whether we have the raw data, it's quite easy. Having the probabilities, I would say it's still straightforward. It's just understanding the nature of that relationship that can be a little bit more tricky. So let's go ahead and do part E now. Just clean this up again. And so this is nothing, let me put in my answer here for part B. So this answer was 0.2. And now, let me clean this up as best I can. Now we're going to look at, let's see, a randomly selected person states that they studied the arts. So now we're sort of going the other way. My eraser's not working. There we go. So this randomly selected person says they're studying the arts. What is the probability that they obtain full-time employment? Okay, so what's the probability that you obtained full-time employment given that you studied arts? Okay, coming back up here to our numbers, given that we studied arts, so all I care about are these individuals who studied arts. Out of them, what proportion obtained full-time employment? Well, I have 51 out of those 64 art students obtained full-time employment. So the probability that I select out by random, given that you studied art, what's the probability that you obtain full-time employment? 51 divided by 64, pretty high, 0.8. 0.80 is that probability, given that you studied arts. There's a 0.8 or an 80% chance that you will obtain full-time employment. Again, I'm going to go through this. You're going to be tired of this. If we divide by 193, so that is my, that is my probability that, my probability that you're full-time and arts divided by the probability that you're in arts. So this is going to be equal to, here's 0.26 divided by 0.33, and that is going to be, where's my calculator, 0.26 divided by 0.33, and that's a little bit more of a rounding error in there, but we're still in the right ballpark. So let's say it's roughly 0.79, around 0.8. I'm going to allow a little bit of rounding error here. That's fine, it happens. So this is going to be 0.79 is that probability. Okay, so there's all of our conditional probabilities. Now I want to come back and discuss just a little bit this multiplication law. It's not part of the problem, so it's a little bit outside of the scope of the problems. But what we've just done, I think I've demonstrated this relationship. So let's say full-time, given that you studied arts. So this is the one that we just did. This is the intersection of full-time and arts divided by the probability that you're in the arts. So what this brings us to is the multiplication law, which is how do I obtain the intersection of two events. And so what the multiplication law tells us, multiplication law, this is if I solve for that intersection, so this would mean that intersection between F full-time and arts is equal to the conditional probability times the probability times the probability that they're in arts. Okay, and that's it. That's our multiplication law. So in order to obtain the intersection of two events, it's equal to the conditional probability multiplied by the marginal probability. Now, if these are independent events, so what that means, if it's independent, meaning the probability of being full-time, given that you're in the arts, if it's independent, then that means that it's not affected by whether or not you're in the arts. So this is what it would mean if these were independent, is that the conditional probability is no different than the probability itself. So if two events are independent, well then I can just substitute this back into here, and we'll find that the intersection of two events occurring at the same time is equal to the product of their two probabilities. Okay, so this little piece that I've done in pink here, this is a bit of an aside. This is outside of the scope of this problem, but I figure it's all part of the same discussion, so we might as well fit it in here. So I hope that this makes sense. Calculating these different conditional probabilities from joint probabilities. You should get lots of practice, and I've got a couple of videos that will allow you to do that. Okay, thank you very much for watching. Bye-bye.